Venture out from the sun, past the rocky realm of Mars, you'll enter a region of cosmic rubble, the asteroid belt. Among the millions of asteroids, a unique world spins Ceres. Ceres isn't just another space rock, it's a dwarf planet, a title reserved for celestial bodies rounder and grander than typical asteroids. Discovered in 1801, Ceres was initially mistaken for a planet. It's significantly larger than its asteroid neighbors. But here's the twist. Ceres harbors a secret beneath its dusty exterior, a secret that hints at a watery, potentially life-supporting past. This tiny world, once overlooked, holds clues to the origins of our solar system and the potential for life beyond Earth. Ceres' story is a captivating blend of astronomy, geology, and the eternal search for life among the stars. For centuries, Ceres was a mere pinprick of light in our telescopes. Astronomers could only speculate about its nature, its composition, and its secrets. It was a distant, enigmatic object shrouded in mystery and intrigue. The more we looked, the more questions we had. Then, in 2015, NASA's Dawn spacecraft arrived. This mission was a monumental leap in our quest to understand the dwarf planet. Dawn's journey was long and arduous, spanning years and millions of miles, but its arrival marked a new era in space exploration. It began orbiting Ceres, sending back images that revolutionized our understanding. These images were unlike anything we had seen before, providing unprecedented detail and clarity. The surface of Ceres, once a blur, now came into sharp focus, revealing a landscape both familiar and alien. One feature stood out: bright spots. These luminous patches were scattered across the surface, catching the eye and sparking curiosity. They were unlike anything we had expected to find. These unusual markings shone brighter than anything else on Ceres, even outshining the sun's reflection. The contrast between the bright spots and the dark, cratered terrain was stark and striking, making them all the more mysterious. Scientists were baffled. What could be so reflective? Theories abounded, ranging from ice to volcanic activity, but none seemed to fit perfectly. The bright spots defied easy explanation, challenging our understanding of planetary science. The answer turned out to be both simple and profound: salt. This revelation was both surprising and enlightening, offering a new perspective on Ceres' geological history. These bright spots weren't just ice. They were massive deposits of sodium carbonate, a type of salt found in Earth's oceans. This discovery was groundbreaking, suggesting that Ceres had a more complex and dynamic history than previously thought. This discovery sent shockwaves through the scientific community. It challenged existing theories and opened up new avenues of research. Scientists around the world were eager to learn more, to dig deeper into the mysteries of Ceres. It hinted at a past where liquid water, perhaps even a vast ocean, existed on Ceres. This was a tantalizing possibility, suggesting that Ceres might have once been a more hospitable place, with conditions that could have supported life. The presence of salt on the surface was like finding a message in a bottle, a message from Ceres' watery past. It was a clue, a hint of a time when Ceres was very different from the cold, barren world we see today. It was a tantalizing clue that demanded further investigation. Scientists began to plan new missions, new studies, to uncover more about Ceres' past and its potential for future exploration. The mystery of the bright spots deepened, pulling us further into Ceres' hidden history. Each new discovery added another piece to the puzzle, revealing a world that was far more complex and intriguing than we had ever imagined. The story of Ceres was just beginning, and the bright spots were the first chapter in a tale that promised to be full of wonder and discovery. The early solar system was a chaotic place. Planetary embryos collided, asteroids careened through space, and the building blocks of planets were scattered far and wide. Ceres, forming in this tumultuous era, likely contained a mixture of rock and ice. This wasn't ordinary ice, it was mixed with salts and other minerals, creating a kind of cosmic brine. Deep within Ceres, a process was unfolding. Radioactive elements, remnants of the early solar system, were decaying. This decay released heat, slowly warming the dwarf planet's interior. Over time, the heat became intense enough to melt the ice, forming a vast, subsurface ocean. This ocean wasn't a tranquil paradise. It was a dark, pressurized environment sandwiched between a rocky mantle and an icy shell. But even in this alien environment, the presence of liquid water raised a profound question. Could life have arisen in this hidden ocean? Section 4. The Slow Freeze. The Fate of Ceres' Liquid Embrace. Ceres, the enigmatic dwarf planet nestled in the asteroid belt between Mars and Jupiter, has long fascinated scientists and space enthusiasts alike. Its surface, marked by mysterious bright spots and occasional geysers, hints at a dynamic past that is slowly being unraveled by modern space exploration. Billions of years passed and the interior of Ceres began to cool. This cooling process was not sudden but rather a gradual decline in temperature over eons, a slow freeze that transformed the once active interior into a more dormant state. The radioactive fuel that had once powered its internal furnace dwindled. These radioactive materials, which had provided the necessary heat to maintain a subsurface ocean, decayed over time, leading to a decrease in internal heat production. As temperatures dropped, the subsurface ocean began to freeze. This ocean, hidden beneath a thick crust of ice and rock, started to solidify, turning from a liquid state into a solid mass of ice. Water expanded as it froze, putting immense pressure on Ceres' surface. This expansion is a natural property of water, which increases in volume as it transitions from liquid to solid, exerting significant force on the surrounding materials. This pressure likely caused cracks and fissures, allowing some of the ocean water to erupt onto the surface. These eruptions would have been dramatic, with water spewing out through the cracks and quickly interacting with the harsh environment of space. The water that reached the surface wouldn't have lasted long. In the vacuum of space, exposed to extremely low temperatures and lack of atmospheric pressure, the water would have rapidly evaporated. Exposed to the frigid vacuum of space, it would have quickly boiled and sublimated, leaving behind only the salts and minerals it carried. This process of sublimation, where water transitions directly from a solid to a gas, would have stripped away the liquid, depositing the remaining minerals on the surface. These deposits, preserved for billions of years, are the bright spots we see today. These bright spots, composed primarily of salts and other minerals, are a testament to the ancient activity that once took place on Ceres. But what happened to the rest of the ocean? This question has intrigued scientists, leading to numerous studies and hypotheses about the fate of Ceres' liquid water. Scientists believe it likely froze solid, forming a layer of ice kilometers thick beneath the surface. This thick ice crust acts as a protective layer, preserving the history of Ceres' internal ocean. However, some pockets of liquid water may still exist deep within Ceres, remnants of its once vast ocean. These pockets, insulated by the thick ice above, could potentially harbor the last vestiges of Ceres' liquid embrace, offering a tantalizing glimpse into the planet's dynamic past and the possibility of future discoveries. Section 5. Hidden Depths. What lies beneath Ceres' icy shell? Today, Ceres stands as a frozen relic of a bygone era. This dwarf planet, nestled in the asteroid belt between Mars and Jupiter, has long intrigued scientists and astronomers alike. Its icy exterior and mysterious composition make it a subject of intense study and speculation. Its surface, scarred by craters and covered in salt deposits, hints at a dramatic and dynamic past. These features suggest that Ceres has undergone significant geological processes, possibly including cryovolcanism, where icy volcanoes erupt with water or other volatiles instead of molten rock. But beneath this icy facade, secrets remain. The true nature of Ceres' subsurface is a puzzle that scientists are eager to solve. What lies beneath the surface could provide answers to some of the most profound questions about our solar system's history. Scientists are eager to learn more about the composition and structure of Ceres' subsurface. They use a variety of tools and techniques, from radar imaging to spectrometry, to probe beneath the icy crust. Each piece of data brings them one step closer to understanding this enigmatic world. Is the ice pure water ice, or is it mixed with other volatile compounds like ammonia or methane? These questions are crucial because the presence of different compounds can tell us a lot about the conditions in which Ceres formed and evolved. Could there be layers of different types of ice, each preserving a snapshot of Ceres' evolution? By studying these layers, scientists can piece together a timeline of events that have shaped Ceres over billions of years. The answers to these questions could reveal crucial details about the early solar system and the conditions under which planets like Earth formed. Understanding Ceres' composition and history can provide insights into the processes that were at play during the formation of our solar system. Ceres, in a sense, acts as a time capsule, preserving conditions that existed billions of years ago. This makes it an invaluable resource for scientists who are trying to reconstruct the history of our solar system. By studying this frozen world, we can gain a better understanding of the processes that shaped our solar system and perhaps even led to the emergence of life on our own planet. The data collected from Ceres can help us understand the distribution of water and other volatiles in the early solar system, which is crucial for understanding how habitable environments might form. The exploration of Ceres is not just about uncovering its past, it's about piecing together the story of our own cosmic origins. Each discovery on Ceres brings us closer to understanding the complex web of events that led to the formation of our planet and the emergence of life. As we continue to explore this icy world, we are reminded of the vastness of our universe and the many secrets it still holds.